Welcome. In this video I'm going to show you how you can perform a Post-Hoc Goodness-of-Fit Test using Pairwise Binary Test and R and my stikpetR library. Now this could be used as an Post-Hoc test for a Pearson chi-square test, for example, of goodness of fit. So Pairwise indicates that we're going to look at every possible combination of two categories and see if those two might be significantly different from each other. I'm using JupyterLab with R version 4.3 and have the basic packages installed. Now the code should actually also simply work in, for example, RStudio. Now I'm using binary test like a binomial or a Wald or a score test, but you could also actually use goodness of fit test for this. Or you could, if you're only interested to know if it's significantly different from the expected count, use a residual test. But in this video I'll focus on the binary test and pairwise. So to show you how this can be done, let me get rid of the index. I need some example data, so I'll load some general social survey data from 2012 adjusted for some example purposes. Using the readCSV function, I don't actually need all the data, I just need one nominal field, so I'm going to be using a mar1, which is the marital status, and to give you a quick impression I'll use the table function. And as you can see that, for example, 79 people indicated to be separated. Now to use my library you actually need to install it using DevTools. So you can't just use install packages, it has to go through GitHub. Then once you've done that you can load it just as any other library, and the function of interest here is ph, short for post-hoc, pairwise, and then bin, short for binary. I'll simply give you an example, so I'll load the function with the field I've selected and I get all this in return. Now as you can see, this has all the possible pairs of two categories, the sample size of the first category, the sample size of the second category. Add those two and you get the sample size in the pair. The observed proportion of the first category, simply this one divided by that one. The expected proportion, because I didn't specify, it assumes a 0.5 for all of them. Because I'm using a binomial test, there is no test statistic, so that's why it shows not applicable. The p-value or significance, and the Bonferroni adjusted one. Now especially this last one, it's adjusted because we're doing multiple tests, so there's this family-wise error rate that we're accounting for, and this uses the Bonferroni adjustment for this. Now this value, if it's below a predefined threshold of usually 0.05, we would reject the null hypothesis and say that these two would then be significantly different. This e minus 78 indicates that I still need to divide this 7.8 etc. by 10 to the power of 78, so that's going to be 0. And then 78 zeros and then 78. So this one is definitely below that 0.05, and actually if you look carefully all of these are. Now besides this, you could also just specify that you want to do a Wald test or for example a score test. And you could also have perhaps already some predefined expected counts or expected proportions. If you have proportions, just multiply it with the sample size and you have your expected counts. I can actually enter these as a small data frame, and then I can feed that to the function by saying expected count equals my expected counts. I also want to use the small p method for the two-sided with binomial tests. So these are quarks, they are actually passed on to the function that's being used. And here we have then the other results. Now in another video I'll show you how you can do it with other libraries or without any libraries. But I hope this was helpful and thank you for watching.